Hey everyone, welcome back to another video. Now, off the bat, if you're usual here and you're not new, there's a marker in my hand, but more importantly, I'm also standing and there's a whiteboard behind me. So, what does this mean? What's different, you might ask? Today will be a fun one. Today we're going to talk about true and magnetic north. Okay, so this video, I'll tell you off the bat, I want to save you time because this topic, if you already know this topic, it might not be for you. So I want to save you time. But more importantly, what I want to point out and what this video is going to be about is who this is for and who this might be helpful for or to, however we say that. So the title of this video, actually, I don't want to say that because I'm not yet sure what I'll title this video because there's so many ways to title this video. So I'll hold off on saying what the title is because I don't yet know what it is. I'm just recording this. I'm just teaching this right now. And so we'll see where this goes. We'll see what we'll cover. We'll see what topics we get into. But the idea of this video is what I find probably more confusing for students than most other topics when it comes to the private pilot training has to do with the navlog, with cross-country flight planning. And a big part of the confusion that I run into, it's not a confusion, but it's a deep lack of understanding, is true versus magnetic north, more specifically magnetic variation. Okay, magnetic variation or declination, however your instructor might teach it to you. Why is east least and west best? Okay, I'm sure you've heard this, and if you haven't heard it before, you'll hear it. You're hearing it here first. East is least, west is best. Okay, and we'll get into what that means here in a moment. And the idea with this video, my goal here with this video, is that by the end of this video, however long this takes, this is unplanned, unscripted. I have a marker, I have my thoughts, I have a whiteboard. I don't know how long this will take. But my goal here is that by the end of this video, you and I together will have a solid, clear, simple, easy understanding of what magnetic variation is, why east is least and west is best, why if you're flight training in LA, you go negative, you minus, you deduct whatever amount of degrees your dashed magenta line shows on your sectional chart, right? It says whatever number, and then it says east next to it. So we deduct that east is least. That's where that saying comes from. And at the same time, why if you're flight training in in New York or Florida, do you add? So when you plan your cross-country flight with your navlog, your magnetic variation is added to whatever your true course happened to be on your sectional chart. So we'll get into all this, and I want to make sure that by the end of this, you walk away with a simple, clear understanding of what it is we're doing here. Because my goal, if you've watched the channel for a while, if you're familiar with me in any way, even for whatever length of time, one of the things I hope is that it comes across how I'm not into quick, fast regurgitation. Let's get this done with. I don't care how long this video takes. I have one goal here. And my goal with this video is that you walk away feeling like you understand the simple reason why on the east side of the United States, or I should do this, my east, but your east over there, why on the eastern part of the United States we add magnetic variation, and on the western side of the United States we subtract, we deduct. Okay, that's my goal. So if I could achieve this by the end of this video, we achieved our goal. If I could achieve more by the end of the video, meaning if you've learned other things in this video, phenomenal. But one thing I want to try is really stay on topic. I don't want to get into different holes and different stuff, even though there's so many things. I could probably spend 4 days with this whiteboard talking about cross-country flight planning. There's so much. It's like an ocean of stuff. But my goal with this video, and this is where I see a lot of misunderstanding and confusion, not only among students, but amongst instructors too, right? You talk with instructors, and the instructor understands, yeah, east is least, west is best, boom. But when you reach the instructor point, the instructor stage of training, I'll just take a quick sip of my coffee. when you reach the instructor stage of training, we're no longer in territory of regurgitation, of rote memorization, of just being able to tell our student the right answer. Now we entered into territory of we better know a lot more about a topic than what we actually tell our students, right? And I talk about this in a different video. I think the video had to do with, I think it was like check ride tips or something, where if you're preparing for a check ride, you need to make sure that the knowledge you're giving over to your DPE is only a portion of the total knowledge you have of the topic, okay? I think the video was about how to check ride philosophy or how to not dig yourself. I forget what I call that video, but it's true with CFIs too. The amount of knowledge that a CFI must have on a topic must be much bigger or bigger. I don't know how big. That's up to you, how determined or how obsessed you are with making sure that you understand what you teach. But it should be bigger than the portion of that knowledge that you give over to your student. Because what if your student comes back at you and says, hey, I hear what you're saying. Sure, east is least, west and best, but could you explain to me why? Like, why do we do that? You need to make sure that you could offer your student a good, solid explanation, because like I always say, our students are our boss, right? They're paying us. So what we owe them, we owe our students, our clients, whatever you call them, we owe them this solid knowledge of what we're actually teaching them. And we owe them the explanation in the event that they come and ask us questions. Now, sometimes, your student doesn't need to know more than what they need to know, and we all know that. But that's just kind of a small little thing. So for those of you CFIs watching this, I hope this video will allow you to be better prepared when you teach navlogs to your students, to be able to go underneath the surface. Underneath the surface and explain the why behind things. I'm sorry. Okay. All right. Already got off on a tantrum. Classic me. It's all good. Here we go. So, magnetic versus true north. The first thing we must understand about magnetic versus true north, the place this all begins, meaning the reason this is even an issue in flight training, is because when we fly these small airplanes, any airplane really, but specifically thinking small airplanes here, what we have is we're dealing with two types of north at the same time. And anytime you're dealing with two types of stuff which speak two different languages, right? We need to kind of figure out a way for both of those things to speak each other's language. So here's what I mean. The sectional chart, that chart where we plot our courses. So the sectional, and for those of you who don't know what it looks like, I don't have an actual piece of paper here. But this is what a sectional chart looks like. It's that chart that shows airspace and all the good stuff. So that sectional chart has what's called, if you take a look at your sectional chart, it has lines of longitude and lines of latitude and longitude lines. So the latitude lines, basically the lines of latitude, they kind of go around the equator, laterally around Earth, and the lines of longitude go from North Pole to the South Pole. Okay? And it looks like this. Let me move this a little bit here. The lines we have Earth, and again, my drawings won't be perfect today, but you'll get the point. So here's Earth. We have lines of longitude. Okay, which extend from the North Pole to the South Pole. And then we have lines of latitude. Okay? So this would be the equator right here. This whole area, kind of ish, pretty much. And then over here we have the North Pole and the South Pole. So what do we see about the lines of longitude, the ones that extend from the North Pole to the South Pole? Well, what we see is that all lines of longitude end up, if we take them north, because right now we're talking about true and magnetic north, because I'm assuming most people watching this are in the northern hemisphere. And even though, again, everything I say about north is true about south. If I say all lines of longitude lead to the North Pole, it's also true that they all lead to the South Pole. But let's just, for the sake of this video, we'll focus on the North Pole because I want to talk about magnetic versus true north. So we see that all lines of longitude lead eventually to the North Pole. Okay? So no matter where you are on the planet, if you track a line of longitude all the way up, where will you end up? At the North Pole. The North Pole is what we call true north. And it's true because it's true. No matter where you're at on the planet, if you track straight north, you'll end up at the North Pole. Okay. Another easy way to think of true north for the sake of this discussion is you're probably watching this video right now on a screen. So it might be your computer screen. It might be your phone screen. So true north for the sake of this discussion is literally the entire top part of your screen. Okay. So whatever your screen is, whatever device you're watching this video on, true north is the entire top part of the screen. And because of that, no matter where your mouse is, if you're watching this on a computer, let's just talk about a computer for a second. No matter where your mouse is on the screen, if I asked you, how do we get from that point on the screen where your mouse is at to true north? The answer will always be straight up. Straight up. Because no matter where your mouse is on the screen, true north is the entire top portion of your screen. Think of this whiteboard. The true north of this whiteboard is all this right here. Because no matter where on the screen I go straight up, I get to true north, right? So true north is always straight up. When it comes to the Earth's surface or the planet, every time we go straight up, we end up where? At true north. At the North Pole, okay? That's true north. Easy. Magnetic north, on the other hand, is a location on the Earth's surface that actually moves over time, not too much, and it actually happens to be quite a number of miles south of the true North Pole. So it's also known as magnetic North Pole, but let's call it just magnetic north. So magnetic north is somewhere many miles south. Not too many miles south, but it's somewhere south of true north or the true magnetic north. True North Pole. So North Pole, magnetic pole, so true north. Let me delete that to keep it consistent. True north is right here on the top, and then magnetic north is south of it. Excellent. So what is magnetic north? That's, again, a video for a whole other time. An easy way I actually think of magnetic north. So magnetic north is basically a point on the planet with Earth where all of the planet's magnetic fields, they point vertically down. And there's one point on the Earth's surface that this actually happens. So an easy way that I think of magnetic North Pole, or that point where the magnetic fields of the planet point vertically down, I think of it as the CG, the center of gravity of the magnetic fields of Earth, of the planet. Because if you're sitting on a chair, your CG is acting, all of your weight is literally pointing towards the center of Earth through one specific spot. Same with an airplane. Every airplane has a CG, a center of gravity, a one point where all of the weight is kind of expressing, it's kind of being weighed down towards the center of the Earth from that one spot. Magnetic north is that one spot where the magnetic fields all point vertically down. So I think of it as like the CG of magnetic fields. But again, video for a whole other time. I don't want to get off on that. All I want you to know right now is that we have true north and magnetic north. True north is the North Pole. It's that point where no matter where we're at on the planet, you might be backpacking in Europe. I might be in Alaska. Another friend of ours will be in Japan. And we all decided, hey, let's all just track straight north. We'll track a line of longitude all the way north, as far north as we can get. Guess where we'll all meet? At the North Pole, okay? Excellent. So let me delete this. I hope north, true north, and magnetic north make a little more sense than they did a few minutes ago. All right. Good. Back to the sectional chart. So the sectional chart has lines of longitude and latitude, okay? For the sake of this discussion, we're only really concerned here with the lines of longitude because we're thinking here about norths, okay? So when we draw a line, also known as a course, maybe better known to you as the route, right? The route of flight that you're planning. So when you're doing a navlog, you open that big sectional chart up and you start drawing your route. You're trying your course. That line, that course is called a true course. Now, why is that line called a true course and not a magnetic course? Why do you think that's the case? Why not call it magnetic course? Why do we call it true course? Well, if you remember what we said before with the sectional chart, that whole chart that we use to plan our flights, actually is laid out. It's presented to us in reference to which north? True north or magnetic north? And the answer is, oh yeah, the lines of longitude all end up at the North Pole or true north. So the sectional chart is laid out, it's presented to us in reference relative to true north. So it's basically a true north map, right? It's laid out in accordance with true north. If we tracked a line of longitude on our sectional chart straight up, we'd end up at the North Pole. So what that does is every line that we now draw on that map, that true north map, guess what you call that line? Well, a line in aviation is called a course. And because the line was drawn on a true north map, therefore the course is a, you got it, true course. And that's why we call the lines or the route that we draw on a sectional chart true course. It's that simple. It's literally that simple, okay? The sectional chart is laid out. It's a map in reference to true north. You draw a course on it. It's a true course. It's not a magnetic course. It's a true course. Excellent. Good. So far, so good, right? We're planning a flight. We have a sectional chart. We're drawing our course. It's a true course. Excellent. Now, what I want to do is I want to jump away from this sectional chart for a moment, and I want to jump into your plane. Specifically, the magnetic compass, or I shouldn't say magnetic yet, specifically the compass in your airplane. So, depending on the plane you fly, the compass is probably somewhere. Let's say this is the cockpit. Here's the instrument panel. So here's the instruments, the whole thing. Here's the windshield. Here's the yoke, 2 yokes. And then the compass is probably somewhere over here with like lines, and has north, and then lines, and then it has 350 or whatever, okay? And it's kind of a free, swinging, rotating, floating, whatever you want to call it, magnetic or compass. We'll figure out which compass it is in a moment. So it's a compass, right? So that's the compass I'm talking about. And by the way, what I always tell people is when it comes to navlogs, the more you could kind of place yourself in a 1940s airplane while we talk about these things, the easier it will be for you to digest all this information. Because when we talk about these compasses, right, you might be sitting there going, well, what are you talking about? I got a G1000 with a magnetometer, and there's no it accounts for everything, right? So you might get lost a little bit with this conversation, and it might work against you if you need to go and fill out a navlog for your check ride. So the best thing you could do is just kind of imagine we're in a 1940s plane with nothing but a magnetic compass, right? And that magnetic compass, I'm already giving it away. It is a magnetic compass, which you probably knew, right? So the compass in our plane is a magnetic compass. So what is a magnetic compass? I want you to realize something. A moment ago, we said that the course we draw on the sectional chart is called what? True course. Why is it called true course? Because it's the course drawn on a true north map. Exactly. It's a map. The sectional chart is laid out in reference to true north, to the North Pole. Every line you draw on it is in reference to the North Pole or true north. So it's a true course. Now, you might already realize what the problem is. What is the issue? You might see where we're going with this. Here's the issue. On the one hand, we have a flight plan. And let me draw the flight plan here. Let's assume that the flight plan is this. Here's our home airport, and our course goes like this, like this, like that, and there's our destination. So all these here are true courses. Here's the issue. How in the world could we actually navigate and track our true course using a magnetic compass? True. Magnetic. They don't speak the same north. They don't speak the same language. Do you hear the question? Where I come from, we say, do you hear the kasha? Big kasha. Doesn't make sense. Doesn't add up. How in the world? If anything, we should have a true compass in our plane, right? Now the true compass points to the North Pole. And therefore, whatever I figured my course is, let's say 035, now when I slap 035 on my compass, my plane is actually flying 035. But instead, we placed a magnetic compass in the plane, which its north points to what? To a point many miles south of true north, completely different place on Earth. And we treat that as our compass to navigate this flight plan we came up with, which is actually in reference to true north. Do you hear the issue? It's a big issue. I want you to kind of take this issue in. I want you to appreciate the issue. It's a very big issue. I hope you could see the whiteboard, by the way, as I sip my coffee. My throat. It's a very big issue. It's a very big issue. And if you haven't asked yourself this question yet, if you've been doing navlogs for a while and you haven't on your own told yourself or your instructor, hey, instructor, what's going on here? This doesn't make sense. On the one hand, true course. On the other hand, magnetic compass. It's an issue. Not only is it an issue, what I'm going to do now or next is show you just how big of an issue it is and how that issue becomes bigger and bigger the further west or east you actually happen to be from the line of zero variation, which we'll talk about. But it's not only an issue, it's an issue that grows depending on your location on Earth's surface. So we'll go ahead and talk about that right now. But I hope you get this issue that I presented. On the one hand, we draw our course, our route on a sectional chart, which is a map laid out in reference to a true north, to the North Pole, which is why every line we draw on it is a true course. On the other hand, we jump into our airplane and we navigate that course using a magnetic compass. And a magnetic compass, the north on the magnetic compass, guess to where it points to. Does it point to, like we said before, straight up to true north? Or does it always point towards magnetic north? The answer is, well, my magnetic compass, its north, always points to magnetic north. So if my line, for instance, just to keep this simple, let's say my track, my course was just straight up. I wanted to fly straight up towards the North Pole, right? Would my magnetic compass, if I slapped north on there, take me straight up, or would it take me someplace else? Well, you might see where I'm going with this, so we'll talk about that right now. So there's a big issue with this. So let's figure this out. And then I'll wrap it all around with where we started with magnetic variation. What is it? Why does it change with our location on Earth? And just understanding why east is least and west is best. Because I hear people regurgitate this all day long in flight schools. And it's great. I'm all about things that could help you memorize stuff. But I'm also, especially if you're a CFI, I'm also for understanding the why behind things. So here we go. Delete this. There we go. Okay. All right. So back to where we started. What I'll do here on the screen now, I'll actually move away from the microphone for a few seconds and I'll draw something on the screen and then we'll get talking about it. But what I'll start with is drawing out the true north on top. So here we go. True north. True north. True north. So just like we said before, true north is always straight up. One more time. True north is always, I can't hear you. True north is always straight up. Excellent. True north is always straight up. Straight up. I want you to always think true north, straight up. True north, straight up. True north, straight up. I want you to kind of cement that in your head. True north is always straight up. Excellent. Now we'll draw magnetic north. Magnetic north, okay, is many miles south of the true North Pole, which is up here. So magnetic north is many miles south of true North Pole. So the difference between true north and magnetic north is true north being the North Pole or the top of our ball, the Earth, is what it results in is no matter where you are on Earth's surface, if we all go straight up, remember the example, I'm here, a buddy of mine is in Europe, you're in Japan, and we all go straight up, guess where we all meet? At the North Pole. Unlike the true North Pole, magnetic North Pole, or magnetic north, as it's more commonly known, is not a point where we will all meet going straight up. Rather, it's a specific location somewhere on the Earth's surface. It happens to be some miles south of true North Pole. It's right here. And what happens when the magnetic north is only right here and not here and not here and not here and not here is something very interesting. I want to show you. I want to kind of get a light bulb moment going off in your head right now. What it results in, actually I'll use this. What it results in is this. True north is always straight up. Magnetic north is not always straight up. It's specifically literally right here. It's one specific spot on Earth. So what this means is if I happen to be west of it, it is to my right. And if I happen to be east of it, it is to my, I can't hear you. It is to my left. Exactly. Okay, does this make sense? True north is always straight up. Straight up. You could be in Europe, LA, Japan. If we take those longitudinal lines all the way up, guess where we all meet? True north, at the North Pole. Magnetic north is only on one specific spot on Earth. Okay? So if I'm west of it, it's to my right. If I'm east of it, it's to my left. While true north is always straight up. Excellent. Okay. Pause this video. Watch this 100 times. I want to make sure this is as clear in your head as anything. Now we'll add a few things to the board and we'll keep going. Okay. I hope you understand this. This is not complicated. True north is always straight up. Magnetic north is one specific spot on Earth. So depending on my location relative to it will dictate its location relative to me. Okay? All right. Here we go. Now what we'll do, we'll keep that. So far, so good? So far, so good. Take a breath, drink some coffee. Let's take a moment to appreciate our new understanding. Simplified understanding. This doesn't have to be complicated. It's not complex stuff. Something, while we take a little break here, something I often tell students when it comes to weather, for example, especially private pilot weather, it intimidates many students. And something I tell students a lot is, you're becoming a private pilot. You are not becoming a meteorologist. Okay. Now, what does that mean? There's a big difference. Oftentimes, private pilots get this idea in their head when weather comes up that, oh my gosh, there's this whole ocean of weather out there. There's books. You could probably read weather books for the rest of your life until you die and never get through all the weather books that exist. I would probably bet money on that. There's an enormous amount of weather information. I don't think there's a meteorologist who understands weather fully. I don't think there's any computer yet that understands the patterns of weather, which is why it's not 100% accurate. I don't know if it'll ever be, right? So weather is an unbelievably deep thing. And private pilots show up. And for some reason, I get why, unless their instructor tells them that you're not becoming a meteorologist, they fall into this thing where they start going, man, I thought I'm just becoming a pilot. I thought I'm just learning how to land the airplane. And here I am. I need to also become a meteorologist. And then they quit. And it's like, oh, right? It's unfortunate. It's unfortunate for all parties involved. It's unfortunate. So the more you can understand, you're not becoming a meteorologist, you're becoming a private pilot. There's some amount of weather products, weather charts, weather lingo, METARs, TAFs. There's some minimal amount of understanding you should and are expected to know as a private pilot. And that's it. You're not expected to become a meteorologist or to know more than you're expected to know. Now, once you're a pilot, there's nowhere in the FARs that say you are not allowed to learn and read about weather for the rest of your life. Knock yourself out. More power to you. Way more power to you. Good on you, mate. Okay? But let's understand the difference. We're not becoming meteorologists, we're becoming private pilots. Okay? What is it I should know as a private pilot? What is it I shouldn't know as a private pilot? And what is it up to me to study for the rest of my life if I choose to? Understanding the difference between these two is very important. So back to this, you're not expected to become an Earth magnetic true north scientist or whatever the people who deal with this are called. I don't even know. Okay. And I'm sure there's, again, like weather, there's a bunch of probably books that talk about magnetic and true north. You're not expected to know that. You're becoming a private pilot. What you are expected to know is, yes, east is least and west is best. But again, me being someone who believes, know the why behind things. Because if you understand the why, this is no longer, it takes away, you know what understanding the why does? And this is me going off on a tangent. I knew I would, but it's all good. What understanding the why of things does is it takes away that need to memorize and remember. All we need to remember to regurgitate the right answer. There's no more pressure. If I understand the why behind something, you could ask me a question about it in a year and I just run through the why. Oh yeah. And I know the answer. So in a way, when you regurgitate things and when you do rote memorization stuff, there's a lot of added pressure to memorize and remember the right regurgitation. But if you understand the why, everything becomes a lot easier. There's a lot of it in flying where one thing builds on another. So the more I understand one topic, the more I could easily understand another topic. Whereas if I just regurgitated and memorized this topic, now I need to work really hard to regurgitate and memorize this topic because there's no connection or relation between the two because it's all just memorization. So keep that in mind. Okay, back to this. You're not expected to become an Earth scientist. You're just a private pilot. And what I want to make sure that you understand is why east is least and west is best. Why, if you're training in LA, you deduct minus whatever amount of degrees. Why, if you're training in New York, you add whatever amount of degrees. That's my goal. Even though I'm going off on tangents, my goal with this video is that you walk away from this on your next navlog when you look at the variation and you have a clear understanding of what we're doing. That's the goal. Here we go. Okay, now, because I mentioned LA and New York, let's draw them. So let's assume, by the way, for the sake of this discussion, just make things easier, that this whiteboard is the United States of America, the lower 48. So let's draw LA. Nothing here is to scale, but you'll get the point. So let's draw LA. So there's LA. And again, nothing to scale. Let's draw New York. New York will represent the East Coast. LA will represent the West Coast. And then there's everything in between. Excellent. So let's start with LA, and then we'll talk about New York. So let's assume you're flight training in LA, and if you have been training for a while, if you've been doing navlogs, maybe you're new to this, you haven't yet been started navlogs, but let's say you've been doing navlogs for a while, be it private, commercial, flight instructor, whatever it might be, and you're familiar with this idea of east is least and west is best, right? And you've been deducting your variation. You've been subtracting that amount from your true course that you came up with. So let me draw this out, and I'll show you exactly why we deduct. And not only why we deduct on the West Coast, but why we deduct the amount that we do. Okay, so check this out. We said before that true north is always what? Excellent. Straight up. Okay, so we're in LA. True north is always straight up. Easy. Excellent. How about magnetic north? What did we say about magnetic north before? Is it always straight up like true north, or is it always what? Well, what we said before is magnetic north, unlike true north, is not always straight up, right? We won't all meet at the true North Pole if we all kind of followed a line of longitude. Rather, magnetic north is a specific spot on Earth's surface, a specific location, south of true North Pole. And so, unlike true north, magnetic north is not always straight up. Rather, it is either right or left of us, depending on where we are in relation to it. So again, in LA, here's magnetic north, south of our true North Pole, which is right there, the center of Earth, okay, on the top. Magnetic north, relative to us in LA, is it off our right or off our left? It's off our right. So check it out. Boom. So what I just drew out are two trajectories. Okay, I drew out two routes, if you will, two little flight plans. One is our location to true north and our location to magnetic north. I'll say that again. Us to true north, straight up, always straight up, straight up. Us to magnetic north. We happen to be to the left of magnetic north, therefore magnetic north is to our right. So what does this mean before we move on? Well, what this means is this. If we followed a line of longitude from LA all the way as far north as it'll take us, we will end up where? At true north. However, if we got into our airplane in LA and we took off, and let's assume there's mid-air refueling. We never had to land until we reached our destination. And all we did was we followed 360 or north on our magnetic compass for as long as we can go. Where would we end up? Well, we'd end up right here because our magnetic compass points to magnetic North Pole. So if you slap north on there, guess where you're ending up? Over here. So if you don't understand the difference between the line that you drew on the sectional chart, which is straight up, let's say you want to go from LA to Seattle. Let's assume Seattle is straight up, which it's not, but let's assume it's straight up. And you said, oh, here's a sectional chart. Here's a map. Boom, draw the line. And then you take your plotter and you figure out your true course. And let's assume that true course says 360, straight up. And you go, great, easy. And you jump into your airplane and you slap 360 on the magnetic compass. Will you end up in Seattle, or will you end up like, I don't know, somewhere over mid-Canada? You see the issue? Big fat issue. Big fat issue. You see where I'm going with this? Big fat issue. So if we don't understand to begin with that our sectional chart, the sectional map, is laid out in reference to true north, and our magnetic compass speaks the language of magnetic north, we will never reach our destination because we're planning in reference to this and we're flying in reference to this. Let me say that again. We're planning in reference to this and we're flying in reference to this. So one thing you could write down on your paper right now, I hope the mic's not in the way. I'm trying to be out of the way. One thing you could write down on the paper is this. Plan, fly. We plan in reference to true north, and we fly in reference to magnetic north. Do you see the disconnect? It's a big, giant disconnect. It's two different types of north which speak two different languages. How do we figure this out? It's a big, fat, giant issue. Big, fat issue. And it's an issue that's been plaguing us since the very beginning, okay? Because true and magnetic north have been around where they're at before airplanes were even invented. So here we are. We show up in a plane, and we have this great little device which shows us magnetic north, which, by the way, I asked earlier, why don't we have a true north compass? That's almost impossible. It's not, but magnetic north is a device, again, back to sit in a plane that's in the 1940s, right? It's like magnetic fields, right? Here we have a device that just points towards this magnetic north. Cool. So it's much easier in the 1940s to figure out the amount of error and make up for that correction and just use a magnetic compass in the plane, which requires no batteries, no alternators, no nothing, than it is to figure out a G1000 with magnetometers in 2020 or 2024 or 2000 or whatever it might be. So here we go. So far, we have true north always straight up and magnetic north on a specific spot. So we're in LA. So again, what I want you to do is imagine you're in LA with me and you are here. And you're looking literally like this. You're like this and you're looking towards true north. I want you to kind of imagine we're looking towards true north. Just like that. We're looking towards true north. And I asked you, where is magnetic north? If I told you while you're doing this, okay? If I told you point towards true north, where would you point to? Straight up. Excellent. How about if I told you point towards magnetic north, where would you point in LA? Excellent. Off your right. Excellent. So one more time. True north, magnetic north. True north, magnetic north. Okay? Easy. Excellent. So now that we have that figured out and we understand the difference here between these two stuff, let's get talking about what's the big deal. Well, we kind of did talk about the big deal, but we'll talk about variation and how we solve for that. And this will all click in your head as we keep talking. All these light bulbs will go off and you'll go, oh, it's that simple. It is simple. So check it out. LA, magnetic north, true north. And what I'll do here is I'll just draw a little angle, okay? This is the given angle or degrees or amount, whatever English word you want to use, that is actually the difference in LA, I should specify LA, between true and magnetic north. Now, why am I specifying LA? Because if we went to, I don't know, a place that kind of is less west, what's a place that's less west? Denver, Colorado. If we went to Denver, let's say that's Denver, okay? The same thing exists in Denver. Where's true north? Straight up. Where's true north? Straight up. Where's true north? Straight up. If we went to Denver, that's true north. Where's magnetic north in Denver? Well, Denver is still west of that line of zero variation, which we'll get to, meaning Denver is still to the left, to the west of magnetic north. Therefore, magnetic north is to the right of Denver, just like it is to the right of LA. So, same thing. And again, just like before, we come up with an angle. But what do we see about the angle in Denver? Is it bigger or smaller than our angle in LA? Isn't that interesting? Right? The principles are the same. True north is always straight up. Magnetic north never moves. So depending on our location relative to it, the angle or the slice of pizza, however you want to think of it, becomes thinner or wider, narrower or wider. So the angle in Denver is a smaller angle than the angle in LA. Okay, here's the $1 million question. You ready for this? This was amazing. $1 million question. What is this angle called? You'd be amazed. You've heard it before, but now I'll connect it in your head. What's this angle called? Answer. Variation. Magnetic variation. That's what this angle is called. That's it. That's variation that we talk about. That's the variation, the amount that we add or subtract. That's what variation is called. That's what variation is. That's what this angle is called. Variation, magnetic variation, or declination as more professionally known. But we'll call it variation. Most people know it as variation. This is magnetic variation. How do we figure out what the magnetic variation is in your area? So before we go any further, I want to make sure that you understand what that looks like. So if you zoom into a chart anywhere in the country, you'll find a dashed magenta line that literally cuts the country. Like it extends through the whole country. And it looks like this. Here it is. I'm just zooming in. I hope you could see this. It says 12E on there, 12 East. So you see how that dashed magenta line, I hope you could see that. That's literally the variation line. That dashed magenta line that you see on your sectional chart, it exists everywhere. So if you look in your area, you'll find one. That's the variation line. So what's the number on that line, you might ask? The answer is, it's the angle. It's the amount of degrees in your area that true north is off from magnetic north, or magnetic north is off from true north in your area. So I just pulled up the line for LA. So we saw the number 12 and we saw east next to it, 12E. So what is that telling us? It's telling us that in our area here in LA, in our area here in LA, magnetic north is how many degrees? 12 degrees E, 12 degrees to the east of us. So if we're in LA, magnetic north is 12 degrees to the east of us, meaning this angle variation is 12 degrees. It's telling us that magnetic north is 12 degrees east of us in LA. East is to our right. When you look at north, east is to the right. So far, so good? Excellent. Excellent. We'll get to New York in a moment. So far we know a few things. We know that true north is always straight up. We know that magnetic north is on one specific spot on Earth. We know that anywhere on Earth, most places, other than one specific type of place, which we'll talk about here in a moment, have an angle, a slice of pizza, as I call it. And the angle represents the difference between true north and wherever magnetic north is in reference to your spot on Earth. In our case in LA, magnetic north is 12 degrees east of us. Okay, that's magnetic north. Excellent. So now here's how we use variation, and this will click everything together, and you'll understand exactly what we're talking about. But before we actually do that, let's talk about New York real quick. And by the way, this is all true and the exact opposite on the East Coast. So if we look on the East Coast and we look at New York, I hope you could see the whole thing. If we look at New York, okay, again, true north in New York is always, stay with me here, true north in New York is always straight up. Magnetic north, when we're on the East Coast of the United States, we happen to be to the right of magnetic north. Or magnetic north happens to be to our left. Okay, so one more time. This is magnetic north to you training in your Cessna in New York. You are right here. And let me draw you in New York so you know where you're at. That's you again, but now you're in New York. Okay, so you are right there in New York. Same thing like before. We're standing in New York. Okay, could you see that? I hope you could see that. We're standing in New York, and I asked you right now, look towards, we're facing north, true north, and I told you point to true north. What would you do? Excellent. This time, though, I said point to magnetic north. What will you do? Boom! You got it. This time in New York, guess what direction you're pointing in? This time, intuitively, clearly, simply, there's no confusion, guess which direction you point in? You're pointing to your left. Now, why is that? 10 minutes ago, you stood here, or I stood here, we did it together. You did that. When I asked point to magnetic north, what'd you do? We did that. Now, I asked to point to that same magnetic north. What do? You do that. Why are we doing this and not this like before? Answer, because we are now to the right of it, where before we were to the left of it in LA. Do you see why magnetic north either falls to our right or to our left, depending on where we are relative to it? How much to the right or to the left does it fall from us? Meaning how steep or how large this angle will be? Answer, depends on how further east or west we are from it. That will cause the slice of pizza to be bigger. So just like we did here in LA, let's draw the angle or the variation. Boom. I won't pull up the sectional, but you could pull up the sectional if you have one, if you have ForeFlight. Pretty much there's a line going in the New York area. I believe it's 13 degrees. Now on the East Coast, unlike the West Coast, it will say W next to it. Now, why do you think the variation line on the East Coast says W? We're on the East Coast. Well, just like before, this east is telling us that magnetic north is 12 degrees east to the right, clockwise of our location in LA, or from the true north course. Okay, these are all courses. In New York, magnetic north is 13 degrees to the west of our 360 true north course. Okay, it's to the west. So it's pretty much northwest of you in New York, and it's pretty much northeast, east of us in LA. Does this make sense? I hope it does. So it's the same thing in New York, it's the same thing in LA. So the first thing I want to clarify is when you look at your variation lines, what does the east mean? It just means it's to our east. What does the west mean? Means it's to our west. Cool. Back to our original question. What was the whole point of this video? Why is east least and west is best? Why is east least and west is best? Meaning, why do we deduct this number anytime there's an east next to it, and we add this number anytime there's a west next to it? That's really what I want you to understand and take away from this video. Okay? And everything we've been building up to right now, or up to this point, is just for your brain to finally be able to make sense of why is it that we deduct this and add this. Okay? And if you've been following every step, your brain should be primed right now to kind of take this new information on and just understand it. And once you understand it, once and for all, you'll never again have to memorize this. This will no longer be a regurgitation thing for you. You'll be walking into check rides. You'll be walking into your CFI check ride, and you'll be able to get up to the whiteboard and show your DPE, check it out. I don't only regurgitate east is least and west is best, but you could ask me any question you want about north, true north, and magnetic north, and I could explain it to you. That's the goal. That's the goal, especially if you're becoming a CFI. But if you're becoming a private pilot, I want you to understand the reasons behind these stuff. It will just take away the whole memorization thing. Throw it away and understand the why, the reason behind things. Okay. Why is east least, west best? It goes like this. Back to our sectional chart. When we were planning the flight, if you remember from the first thing I drew, when we were planning the flight, that flight plan of yours that you drew, that course, we call that a true course. And we also said that the magnetic compass, or the compass in your airplane is magnetic. It speaks and points to this. So here's the issue. We need to kind of maneuver the airplane along these tracks, which are true courses, while using a compass that points to this. So let's assume that this little flight plan is just in the LA area. And we just said the LA area, or the area that this flight plan goes through, has that line of variation. And it has, if you look at a line of variation, it says 12 east. So we look at that line and we go, oh, in our area, variation is 12. Meaning, again, the angle between true and magnetic in our area where this flight plan is happening is 12 degrees. Meaning it's 12 degrees to our east, off to our right. So here we are. We get into our plane and we have a magnetic compass. And let's say this true course, we took our plotter and we figured this true course is, let's say, 045. Hypothetically. And then we figured this course is, 355. And then this course is 035. And then because again, you following me? 045 is like northeast. This is pretty much north, maybe a touch to the west. This is again northeast. This is north, maybe a little more to the west, so 350. And then this is like way almost west, so we'll call this, 290. Okay, let's say that these are the true courses that you came up with your plotter. Now, if we got into the plane like we're talking about before, and you looked at your magnetic compass and slapped 045, would the plane fly this? No, because now it's slapping a 045 of this north, not of this north. Okay? And this north happens to be to the right of true north. So if we got into our plane and we flew 045 magnetic with our compass, guess what our plane will do? It will end up 12 degrees off course every single time because it's to the right. Okay? This angle exists. So we need to correct for this angle. So our goal is to actually fly true courses using a magnetic compass. And we could do that if we A, know what the error amount is, and B, correct for it. Do we know what the error amount is? Yes. So let's keep it simple and say we want to fly from LA to Seattle. We said before that Seattle is, assuming, just for the sake of this discussion, straight north from LA. So let's say Seattle is right there. Okay? And we want to fly from LA to Seattle. This is our flight plan, true course. 360. We drew it on the sectional chart. We figured out with our plotter 360. Again, you're an expert at this point. If we got into the plane and we just slapped 360 on there, north, would we end up in Seattle? No, because our magnetic compass points 12 degrees off to the right in this area. So guess what? Over time, we will be falling further and further to the east from Seattle. How do we correct for this error? Well, you might ask, we first need to know, not ask, you might say, we first need to know what the error is. It's 12 degrees in our area. Cool. So do we need to add 12 degrees and then be offset even more? Or do we need to deduct 12 degrees to get back on our true course and actually track this course with our magnetic compass? Answer is we need to go counterclockwise and deduct. We need to deduct. We need to go from here back to there. So now when we deduct that and we figure out our actual magnetic course, which by the way, our true course here was 360, we deduct 12 degrees. How much is this? 360 minus 12. 3, 4, 8. So now we get into the airplane. Now guess what? Our magnetic course is 348. Now if we slap 348 on our magnetic compass, we're tracking this true course that we drew on the sectional chart. And we actually have a chance now of ending up at our destination. But what did we do over here on the West Coast? We subtracted. We went counterclockwise, because if we added, we would be even further off course. So basically the goal is, what we need to do is go from magnetic to true. And on the West Coast, or west of magnetic north, it's counterclockwise. Going from magnetic to true on the West Coast is counterclockwise. We need to deduct. We're going from magnetic to true on the East Coast is clockwise. We need to add, because if we subtracted, we'd fall even further off course. We're trying to get here, back here. We're trying to bring this magnetic to true, which is why east is least. Anytime you see E on your sectional chart, you subtract. Why? Because magnetic north falls off to your east by whatever amount of degrees it says. How do we come from east to north? Counterclockwise. We subtract the degrees. We go from 360 minus 12 to 348. On the West Coast, it's the exact opposite. Magnetic north is off to our left. It's east of us, or we are west. It's west of us. We are east of it, which is why it says W. We need to bring that magnetic back up to true. So now we could actually follow this true course using a magnetic compass. How do we bring magnetic to true on the East Coast? Clockwise. Add. East is least. West is best. I hope this makes sense. I watch this a million times if you have to. This is why anytime you see E on your line of variation, we subtract. Okay? That's an easy one to remember. Just remember E, I subtract, but now you understand why we're subtracting. We're bringing it from ending us up here to ending us up in Seattle. Okay? Because if we took off here and we slapped north on our magnetic compass, we'd end up more and more off course, because it's pointing to magnetic north, your compass. So we need to make that correction. In LA, it's 12 degrees. Subtract. Going from magnetic to true on the West Coast is counterclockwise. We subtract. Going from magnetic to true on the East Coast is clockwise. We add. That's the goal. So I want you to write a few things down on your piece of paper. And if you don't have a paper, pull one out. Let me just take a little coffee. I want you to write this down. Our goal is to go from magnetic to true. Again, this is confusing, I realize, because we actually, on the navlog, we start out with true, and then we end up with magnetic. Not end up, but then we go to magnetic course, and then we get our wind correction angle, and then we have a magnetic heading, which is a whole other video. But the goal here, pretty much with the variation, is how do I get my magnetic compass to now point towards the true North Pole instead of point towards here? Because if I can get my magnetic compass to actually point to the North Pole, now I could use that compass to actually get myself to the North Pole. And how do I get myself to the North Pole using a magnetic compass? Well, if I'm in the LA area, I fly a 348. If I'm in the New York area, 360 plus clockwise 12 would be 012 or 13, 013. I slap a 013 on there, and I end up going from New York straight to the North Pole, true North Pole. That's the goal. The goal is how do we accomplish this true course flight plan using a compass that loves to point to this. Okay, no problem. You want to point to this? Keep pointing to this. Keep doing your thing. All we need to know is what's the variation? What's the angle in our area? And looks like Denver, I haven't checked, but I don't know, Denver's less. Let's call Denver 7 degrees, right? And we'll say east, right? Because it's same thing like LA. One more thing I said we'll talk about, which I didn't, and we'll finish with that, is if you look at your sectional chart, Minneapolis area actually happens to fall pretty much somewhere in this area here. Again, nothing is to scale. And something very interesting happens with the area of the country right over here. And that is, look at what happens to the angle between true and magnetic in this area. So here's true, straight up, always straight up. But what's the angle to magnetic in this area? Oh, it's the same thing. It's almost like a solar eclipse. Magnetic is in the way of true, right? So the moon is blocking the sun. So now what happens to our angle, the variation? Well, there is no angle, because in this area, if I slapped north on my magnetic compass, guess where I'll be flying to? Not only will I be flying towards magnetic north, I'll also be flying towards true north, which is straight up. So if you look at the variation line in the Minneapolis area, just a fun little fact, it says 0. It doesn't say east or west. There's no variation there. There's no angle. So for those of you doing your navlogs in the Minneapolis area, and by the way, it's not just Minneapolis, it's literally all down south along that trajectory in the country. Just if you, I know Minneapolis off the top of my head happens to be that. So if you're doing your navlogs there, you know very well that when it comes to your navlogs, the difference between true and magnetic is 0. You're not adding and you're not subtracting anything. So all you have left to do is really wind correction angle and deviation. That's a video for another time. But right now, we're specifically looking at the angle, and there is no angle. So there's no difference there between true and magnetic, because if I took a magnetic compass and flew straight north, I therefore also will be moving straight up. So where's true north? Straight up. Where's magnetic north? Depends. If I'm to the west of it, it's to my right. If I'm to the east of it, it's to my left. If I use a magnetic compass and I want to use that compass to track a true course that I drew on my sectional, I must understand this discrepancy or this error, this amount that they're off, and correct for it. So if I want to actually fly straight to the North Pole using a magnetic compass in a plane in LA, I fly 348. If I want to fly straight to the true North Pole in New York using a magnetic compass, I fly a 013. I add the 13 degrees. So that is why east is least, we subtract counterclockwise, and west is best, we add addition. Okay? I know this could seem like a lot. Okay, there's a lot of words I said, blah, 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 the whole thing. There's a lot going on. Watch this video 50,000 times if you need to. especially if you're becoming a CFI. Your student, you owe it to your student to be able to explain this to them if you happen to have the student who's like obsessed with wanting to know more. You owe it to your student. You work for your student. Your student is your boss. Okay, and I talk about this a lot. We CFIs serve our students, not the other way around. Not the other way around. And your students deserve this. Your students deserve a CFI who could explain these things. Okay, so if you're a CFI, if you're becoming a CFI, hold yourself to this. If you can't walk through something on a whiteboard like this, learn it to a deeper degree until you can. Okay, and by the way, explaining this, I don't know how long this video has been going on for. I'm not looking at a clock or anything, but you don't have to. You could take an eighth of the time I took to explain this, because again, I went off on tangent and I spoke about stuff as I always do. It doesn't have to be this long. But we serve our students, so keep that in mind. And if you're a student watching this, if you are new to Navlogs, or maybe you're a commercial and you're doing a Navlog and you haven't yet understood this, maybe you're thinking about your CFI, it's this simple. It's this simple, okay? But what we did here is we took this whole East is least and West is best slogan, broke it down, and explained step by step why East is least and West is best. As always, hope this was helpful. Hope you took good notes. Like I said before, watch this as many times as you need to. Study it, go over it. And you'll find the more you understand these things, the less you have to memorize and remember and regurgitate. It's a lot of energy to memorize these things because there's so many acronyms and slogans and stuff. But as long as you understand something, think of it this way. Understanding something fully might take more energy initially. Like going through this with me right now, fine, took a little more energy than it would to just regurgitate something. But what this did is now for the rest of your life, this knowledge is in your head and you no longer have to memorize anything about it. You understand it. True north is always straight up. Magnetic north, I don't know, could be off my right, could be off my left, depending on where I'm at geographically. Right? There's an angle between the two. Oh, I'm using a magnetic compass. I need to correct for that angle. Oh, that's why we add and subtract. Once you understand these things, goodbye memorization. We're done. We don't have to memorize any of it. So just keep this in mind. Hope this was helpful. I really, really, really do. And I hope this helps you in your flight training journey. And I hope that from this you realize that even material that might intimidate you and you might initially think, oh, I could never master this. Remember what I said. We're not becoming meteorologists. We're becoming private pilots. We're not becoming earth scientists or whatever you call people who deal with these north stuff. We're becoming private pilots. And the scope of knowledge is not nearly typically as deep and as wide as most private pilots think it has to be, right? And then they give up. Don't give up. Figure out, well, what do I need to know? And whatever it is you need to know, master. And let me tell you a little secret. In the grand scheme of things, it's not much, especially if you're becoming a private pilot. So keep that in mind. I hope you kind of took that away from this video too. Anyhow, until next time, fly safe. Hope this helps, and I'll see you on the next one.